Hello, ladies and gentlemen. My name is Perumal Jegan. Recently, I came across a interesting TryHackMe room. It's a walkthrough based room. Talks about core components of Windows operating system, and the room name is Windows Internals. Especially, I found the room was very useful. Hence, I wanted to abduct the same feel to my viewers as well. Hence, I am here making this video. Without wasting a time, let's begin. Here we are. This is the room, Windows internals. Let's see the description. Learn and understand the fundamentals of how Windows operates at its core. So it's going to be a fundamental room. And the introduction part, operating systems have a lot more technology and architecture behind them than we may see at first. In this room, we will be observing the Windows operating system and common internal components. Learning objectives. So, this is the objective of this room. Understand and interact with Windows processes and their underlying technologies. Learn about core file formats and how they are used. Interact with Windows internals and understand how the Windows kernel operates. So it gives some in-depth analysis of Windows operating system. And with Windows machine making up a majority of corporate infrastructure, red teamers need to understand the Windows internal and how they can be abused. Not only red teamers, you may be a blue teamer or purple team, whatever. Uh, Having a knowledge of Windows operating and any operating system that will eventually help you. The red team can abuse Windows to aid in evasion and exploitation when crafting offensive tools and exploits. Before beginning this room, familiarize yourself with basic Windows usage and functionality. Basic programming knowledge in C++ and PowerShell is also recommended but not required. Okay, for this room. So here is the machine they gave. Not only the theoretical concept, they also gave their machine. I already connected that machine and took the RDP. So here we have the required files, the exercise files in these three folders. So we're going to use these files while we are learning all those theories. We are also going to perform some practical triaging, practical analysis. Okay, so let's begin. This is just an information so completed. You can see the topics here. So these are all the topics that we are going to learn from this room. We are going to learn about Windows processes and what is thread, virtual memory, and dynamic link libraries. What is DLL files and portable executable format? We say PE format, right? So this particular part explained about that file format and also interacting with Windows internals. So finally, a conclusion, of course. So let's move to the first topic, processes. A process maintains and represents the execution of programs. An application can contain one or more processes. A process has many components then it gets broken down into be stored and interacted with. The Microsoft document, they also gave a Microsoft link which describes the Windows processes and its subcomponents. Break down these other components. Each process provides the resources needed to execute the program. A process has a virtual address space. So this is very crucial point. Every process must have a virtual address space and an executable code, open handles to system objects, a security context, a unique process identifier. So every process given a unique ID. Usually it is number. We call it as a process ID. So that is what they gave. And environment variables, a priority class, minimum and maximum working set sizes, and at least one thread of execution. So these are the components of every process. This information may seem intimidating, of course, but this room aims to make the concept little less complex. Uh, let's see how it makes the lesser complex. As previously mentioned, processes are created from execution of an application. Processes are core to how Windows functions. Most functionality of Windows can be encompassed as an application and has a corresponding process. So this is another important point. Below are few examples of default application that starts process. So here they gave some default process names and the application name in the bracket. So I already logged in the Windows machine, right? Let me go to the task manager. If I open the task manager, I'll be able to witness the list of processes. So here I can see it lists the processes, and I can see so many processes opened by default. So these are all the existence of an executing, I mean, the program that is being executed. So this is just an existence of a program. So that is called a process. And let's see what are all the, let's see the next slide. Attackers can target processes to evade detections and hide malware as legitimate process. If you are a malware researcher, then this part would be very helpful to you because it talks about process. Malware authors often use processes to hide their malware. So that is what they are saying here. Below is a small list of potential attack vectors attacker could employ against processes. So here you can see some attack techniques that employed by malwares. So let's see here: process injection, process hollowing, process masquerading. So if I go to this specific link, it will be redirected to Mitre framework where they defined that specific process and its definition. Let's see process injection. Uh, Adversaries may inject code into processes in order to evade process-based defenses as well as possibly elevate privileges. Process injection is a method of executing arbitrary code in the address space of separate live process. So when a malware author is injecting any malware, they wanted to execute that malware, right? When they are executing that malware, every application will create a process, right? So without creating the malware's own process, what the threat actors do, they try to inject their malicious code into another existing benign process so that it can evade the detection, it can dodge the antivirus and the security solutions. So that is the concept of this process injection. And process hollowing is also a similar concept. Process hollowing is all about creating a process in terminated state, and it is not active process, but the while creating the process itself, they create it as a terminated process and they inject the code into the terminated process to evade the detection, of course. So that is a technique of process hollowing. And also process masquerading is a similar process. So process have many components. They can be split into key characteristics that we can use to describe processes at high level. The table below describes each critical component of processes and their purposes. So this is very important technique. Actually, this specific table defines the high level components of every process. So let's see what are all the components. Private virtual address space. So virtual memory addresses that the process is allocated, and executable program defines code and data stored in that virtual address space. So in this virtual address space, the code needs to be, the code will be inserted. And open handles defines handles to system resources accessible to the process. I'm not quite sure about this term as I'm a beginner to this. Let's move to the next one. Security context. The access token defines the user, security groups, privileges, and other security information. Every process has some privilege level. So, for example, if I go here in this room, I'm already in the task manager, the list of processes I'm viewing. I can see the username here. Some username is system, some username is THM attacker. If the username is system, then it is top privilege. THM attacker, limited privilege. So like that, every process has some privilege constraints. So if I go to the properties by right clicking it, I can see all these things in detail. If I go to the security tab, here I may see what are all the permission that specific process has. And further details I can view here. The size, the signatures, the details, security, general. If I see generally, here is the type of file and the file location. So everything is given here. So I just right click the process and I open the properties to read all these informations. If I go here, I can see the process ID and threads as well. So here is the process ID. I tried to find the thread ID. I couldn't find in the task manager. Maybe we can use some other Windows internal tools to witness the thread ID. Okay, let's move to the next one. We can also explain a process at lower level as it resides in the virtual address space. The table and diagram below depict what process looks like in memory. So this particular below components are low level components of the process. So when you look as a user point of view, you can see these components, but as a machine point of view, this will look these components only. So let's see, it is code, the same thing here, executable program, the code executed by the process, and global variables, stored variables, purpose, and the process heap defines the heap where the data is stored. It's a kind of memory, and process resources defines further resources for the process. Sometimes a process might be dependent on some other thing, so that is what they gave here. And the last element is environment block, data structure to be, data structure to define process information. So here you can see the diagram where they gave the structure of the process at low level. The code, global variable, process heap, process resources, open file heaps, environment blocks, and the threads. The thread can be anything. Minimum, at least, it should have one thread. It can be more than that. This information is excellent to have when we get deeper into exploiting and abusing underlying technologies, but they are still very abstract. We can make the process tangible by observing them in the Windows Task Manager. The Task Manager can report on many components. We already seen the process list in the Task Manager. This task manager can report many component information about the process. Below is the table, brief list of essential process details. So here they give some of the essential details of every process: the name, process ID, process status, and the username. If I go here, I can see the process status as whether the process is running or suspended. I said the process hollowing technique, right? So the process hollowing technique is actually used by the malware authors. The malware usually uh, creates a process in a suspended state, and it injects its code into that specific suspended process. So that is the process. So there are what you would interact with the most as an end user or manipulate as an attacker. So there are multiple utilities available that makes observing processes easier, including Process Hacker, Process Explorer, ProcMod. So these are the tools that used to view the list of processes and its components. So compared to viewing the process in the task manager, if you use these tools, it will be very easy to know few other informations in an easy manner. Processes are at the core of the most internal Windows components. The following tasks will extend the information about processes and how they are used in Windows. So here we are. Open the provided logfile.yml in proc mode and answer the questions below. So here is our exercise. So we are going to open the file in proc mode. So if I go to this specific folder, process monitor, I can see an application, ProcMon64. So this is what the application that I need to spawn. So let me spawn this. I can also see the file here, logfile.pml. So this is the file we are going to open, and we are going to read the information in that file and want to answer to some of the questions that we asked. I just opened the process monitor. When I open the process monitor, it displays the list of processes that is running in this specific Windows machine. And it is live process list. Not only process details, I can also see the registry activities, file system activities, and network activities, process and thread activity, and eventually profiling events. So I can see these many events here in this process monitor, proc mode, and I can also filter out what are the options that I need to see. Now I just chose process and thread activity alone. So here I can see all the process and its related thread activity. But this is what, this is not what we wanted. We need to load another PML file, the procmon file. So if I go to the process monitor, I can see this log file. I'm simply loading that specific file. All right, we just loaded logfile.pml file. Now it is time to answer those questions. What is the process ID of notepad.exe? We need to find the process ID. Actually, it is quite simple. I just chose the process and thread activity. I need to find the process ID of notepad.exe. If I scroll down, I can see bunch of processes running, but I can do filter this stuff. I can choose the scroll down, and here I can see the process name. I'm just choosing the process name, and the process name is notepad.exe. And when you filter it out, here I can see the process related to Notepad, and the process ID also we got. It is 5984. So that is what the answer, 5984. And if I see the hint, you can filter the process name by process name in procmod. So that is what we just did. So what is the parent process ID of previous process? What is the parent process ID of previous process? Let's see the hint found in the event properties of the process. So let's go to that. If I'm going this, I mean, if I'm going to this and trying to click and open this, I'm just trying to see the parent process ID. If I see this event tab, I can see the parent PID here. It is nothing but 3412. That is for notepad.exe. So let's try to answer that. 3412, that must be the answer. Yes, it is. What is the integrity level of the process? So what is integrity level? Let's read the hint. Found in the process tab of the event properties. This is the same thing. We need to move to process tab, integrity level. So let's move to the process tab. If I go and see the parameters here, I can see the parameter called integrity, and the integrity level is high here. So that must be the answer. Yes, it is. We successfully finished this process exercise. Not only these questions, you can go through all other components. You can use Procmon to explore the random processes that you came across. It will help you to understand the process monitor better. And let's move to the next exercise. It is threads. Let's see what is threads. A thread is an executable unit employed by a process. So a process and a thread is related to each and scheduled based on device factors. Device factors can vary based on CPU and memory specification, priority, and logical factors, and some other factors. And we can simplify the definition of thread. So here is the simple definition: controlling the execution of process. So thread is the component which controls the execution of a process, simply. And since threads control execution, this is a commonly targeted component. All right. Thread abuse can be used on its own to aid in code execution, or it is more widely used to chain with other API calls as part of other. The next slide. Threads share the same details and resources as their parent process do. As such, code, global variables, etc. Threads also have their unique values and data outlined in the table below. We have seen the list of components for every process, right? Like that, even thread has its own components. Let's see what are all the components and its purpose. The first component, stack. All data relevant and specific to thread, exceptions, procedure call, etc. And thread local storage. Pointers for allocating storage to a unique data environment. Stack argument. Unique values assigned to each thread. Like, I mean, for process, we would say it as a process ID, PID. There is a unique identifier for each process. Same as stack argument is for thread, a unique identifier for every thread. And context structure holds machine register values maintained by the kernel. So that is the definition. It is very low level. We can understand it slowly. Threads may seem like bare bones and simple components, but their function is critical to the process. All right, open the provided file. The same file, we already loaded that, and we need to answer the questions given below. What is the thread ID of the first thread created by Notepad.exe? So let's see what it is. So here I can see the process start. At the below, I can see thread create. So here the thread is being created, and I need to find the thread ID of the first thread created by this. So let's see the thread ID. To read the thread ID, if I go to this details column, I can see the thread ID here, 5908. So that is the answer, 5908. If I see the hint, listed option in the, listed as operation thread create. All right. The next thing is, what is the stack argument of the previous thread? So to see the stack argument of the previous thread, I need to go to this specific event properties, and here I think I would see it here. So let me see. Let me refer the hint, listed as thread in event properties. If I see the event property, here I can see 6584. So here is the ID, stack argument 6584. So let's try to apply that. Yeah, that is the right answer. Now let's move on to the next one, virtual memory. What is virtual memory? Virtual memory is the critical component of how Windows internal work and interact with each other. Virtual memory allows other internal components to interact with memory as if it was a physical memory without the risk of collision between the applications. I couldn't understand this line, but if you see the diagram, you can understand it better. The concept of modes and collisions is explained further in task 8. Virtual memory provides each process with a private virtual address space. A memory manager is used to translate virtual addresses to physical addresses. So this is one line to keep in mind. Memory manager is doing some translation between the virtual and the physical address. By having a private virtual address space, not directly writing to physical memory, process have less risk of causing damage. The memory manager will also use pages or transfers to handle the memory. So these are the two components used by memory manager to handle memory. Applications may use more virtual memory than physical memory allocated. The memory manager will transfer or page virtual memory to the disk to solve this problem. You can visualize this concept in the diagram below. So here they give the diagram. The process virtual memory block, in the middle physical memory, at the bottom disk. You can see how it is being uh, directed. You can see the virtual memory is writing to physical memory. All the arrow mark is towards physical memory and the disk. So if I'm moving further, I can see the theoretical maximum virtual address space is 4 GB on 32-bit operating system. So this is the theoretical maximum address space. The address space split in half. The lower half is, so here is the address, the memory address for the lower half of the memory is allowed to processes as mentioned above. The upper half is allocated to OS and memory utilization. If you see the diagram, you can understand. 4 GB in total, 2 GB for system space, 2 GB for process space. And administrator can alter this allocation layout for applications that require a larger address space through settings. So this is an important point. Administrator can alter this allocation layout of our applications that require larger address space through settings. So this specific space is customizable by the user, and for that the utility increase user UVA is being used, or AWE, address windowing extensions. All right. The next stuff is the theoretical maximum virtual space is 256 terabyte on the 64-bit modern system. So this is the diagram. I don't understand why. I know how the 256 terabyte is coming here. It is very huge space, but they are referring 64-bit modern system uh, has the theoretical address space of 256 TB virtual space. The exact, if anyone know, put it in the comment section. I wish to understand this specific line. The exact address layout ratio from the 32-bit system is allocated to 64-bit system. Most issues that require settings or AW are resolved with increased theoretical maximum. Hmm. You can visualize both address space allocation layouts to right. So here is the diagram to understand it better. Although this concept doesn't directly translate Windows internals or concepts, it is crucial to understand. If understood correctly, it can be leveraged to aid in abusing Windows internals. All right. Now let's try to understand, answer these questions. Just an advisory. What is the total theoretical maximum virtual address space in 32-bit system? And it is 4 GB. That is what we read through. And what is the default setting flag can be used to reallocate user process address space? So here we have seen increase user VA. Administrator can also in the application. I mean, administrator can alter this application layout for applications that require a larger space through settings. Increase user VA. So that would be the answer here. That is the default setting flag can be used to reallocate user process address space. All right. Open the provided file. All right. The same file. And we need to answer what is the base address of notepad.exe. So far, we have seen the process ID and thread ID. Now, we are going to collect the memory address where that specific process is being loaded. So, let's see what is the base address of the specific notepad.exe process. So, here is the process. And if I open this, I can see so many information, but the address space that I wish to check, I couldn't see here. Let's see the hint listed as the operation load image. Listed as the operation load image. So let's see here carefully. Operation load image. So here I can see the load image operation. So I'm opening here. If I open, I can see the image base address here. So this would be the answer. Let's try to put the same here. Is that the answer? Yes, it is. Okay, perfect. Now I got to know the load image operation has the base address and also the image size here. And the operation is load image, of course. And I can see the information about the memory address and the size once again here. And the path, the company, the version, and timestamp. So it gives so many information about the specific process. Process monitor is really awesome. And okay, let's move on to the next topic, dynamic link libraries. It is another excellent concept. And when we were starting this room, they advised us to have some knowledge in PowerShell or C++. How, though it is not, like, compulsory. So in this exercise, we are going to see some C++ code. Even I'm not familiar with the C++ code much. So just try to read and try to understand what they gave here. Dynamic link library. Microsoft describes DLL as, so here is the definition. It would be very helpful when you are attending any interview. A library that contains code and data that can be used by more than one program at the same time. So it's a shared library. It can be used by many programs. So that is the definition of DLL. DLL are used as one of the core functionalities behind application execution in Windows. Perfect. From the Windows documentation, the use of DLLs helps promote modularization of code reuse, efficient memory usage, reduced disk space. I'll explain what is the excellent benefit of using DLL. DLL is a shared library, right? It contains certain code, certain utility. So any program that is being executed, uh, it can simply catch, it can simply refer that DLL. When someone is creating any executable, they need not to add all the required files within the executable. they can simply call the executable in externally without keeping all the contents in the executable. That is called dynamic linking, but that is the topic for another video. So here, just try to know, it's a shared library, the library that is being shared by so many applications, as simple as that. And the operating system and the program load faster, run faster, less disk space in the computer. When a DLL is loaded as a function or in the program, the DLL is assigned as a dependency. Since the program is dependent on DLL, attacker can target the DLL rather than applications to control some aspects of execution of functionality. So here they gave some of the techniques. Again, Maitre technique. Let's try to open one of these techniques. DLL hijacking, for example. Even the DLLs can be uh, manipulated or leveraged by threat actors. That is what, that is the concept here. So that is what they gave. So it is necessary to understand, as a security researcher or a securities analyst, you must know the process, these sort of techniques. And let's understand what is process DLL hijacking. Adversaries may execute their own malicious payloads by hijacking the search order of the used to load the DLLs. Windows systems use common method to look for required DLL to load for a program. Hijacking DLL loads may be for the purpose of establishing persistence, as well as elevating privileges or evading restrictions of the execution. There are many adversaries that can hijack DLL nodes. Adversaries may plant Trojan dynamic DLL files in a directory that will be searched before the location of a legitimate library, and it will be requested by a program. So what they are doing is they are just trying to make their own malicious DLL. So when the program is being executed, it obviously calls DLL, right? So they try to place their compromised malicious DLL in the legitimate DLL place. So that is what the DLL hijacking is all about. Perfect. Now let's try to understand further. DLLs are created no different than any other project application. They only require slight syntax modification to work. Below is the example of DLL from the Visual C++ Win32 dynamic link library project. So here they gave a sample DLL file. So this is how a typical DLL file will look like. Below is the header of the file. They gave the headers separately. It will define the functions that are imported and exported. So here they are defining the imported and exported functions, and we will discuss the header file importance in the next section. Okay, and the DLL has been created, but that still leaves the question of how the DLL is being used by the application. That is the big question in front of us. So let's see what is the answer. DLLs can be loaded in program using load time dynamic linking or runtime dynamic linking. So there are two concepts to load any DLL into a program. That is what load time and runtime dynamic linking. Uh, when loaded using load time dynamic linking, explicit calls to the DLL functions are made from the application. All right, you can only achieve this type of linking by providing header and import library file. So in the DLL itself, they specify the header file and also the import library file, so that they can explicitly call the DLL file while executing the program. And below is the example of calling exported DLL function from the application. So here they gave a simple code that they are calling the exported DLL from the application itself. So here is the application, a simple hello world application, and they are calling the sample DLL here over the header. So that is what we said. So this is all about the concept load time dynamic linking. And let's see the next concept. When loaded using runtime dynamic linking, a separate function, load library ex, is used to load the DLL at runtime. So here they are not calling that library in the header. Instead, they are using some separate functions to call the DLL during the runtime. So once it is loaded, you need to use get process address to identify the exported DLL function to call. Below is the example of loading and importing DLL function in an application. So here is the application. There they are using the load library function to call the DLL, and also they are using get process address identify the exported DLL function to call. So here is the simple program that explains the runtime dynamic linking. All right. In malicious code, threat actors will often use runtime dynamic linking more than load time dynamic linking. So threat actors often prefer to use this specific runtime dynamic linking rather than load time linking. This is just an information. This is because malicious program may need to transfer files between memory regions, and transferring single DLL is more manageable than importing using other file requirements. So that is the definition for the maximum usage of runtime dynamic linking. All right. Now let's try to answer the same. Again, the same file we are going to use. What is the base address of ntdll.dll loaded from notepad.exe? So let's try to find the base address of ntdll. If I look at the list here, I'm trying to find the ntdll DLL file. So I need to find the address of that specific DLL. So I'm just trying to find that. Uh, let's see the hint listed in the operation load image of ntdl.dll. So let's see operation load image. Let's try to filter the operation load image, and yeah, and here I can see ntdll, and I need to find its base address, right? So here is the base address given. So let's try to read that, and let's try to open this and copy the address. And here I can see the base address of ntdll.dl. So here is the address. That's the right answer. And what is the size of ntdll.dll loaded from notepad.exe? And let's see, this specific DLL is loaded by notepad.exe, and I can also see the size here at the bottom, the image size. So that is what they are asking us to enter. Yeah, that's the right answer. And how many DLLs were loaded by notepad.exe? Let's see the hint. Filter the operation load image in prop mode. So let's try to filter the load image operation prop mode. We already did the load image filtering, and in the list I can see 53, but that is not the exact answer. If I see, I can see what I mean. If I see here, there is one executable file. Also, if I scroll down, I can see here there is one .drv file. So subtract these two files from 53, then the answer is 51 here. That would be the answer. Yes. Next topic is portable executable format. Executables and applications are large portion of how Windows internals operate at higher level. Especially if you are doing malware analysis, you would probably handle these portable executable files often. So then you must have the knowledge of this file structure. So that is what they gave here. They tried to explain the basic structure of the PE file. So it would be very helpful when you are doing the malware analysis, as I said. So let's see, PE, shortly it is called PE, portable executable format, defines the information about the executable and stored data. PE format also defines the structure of how data component of stored, how data components are stored. Actually, it's a file structure. It is not a file type, it is like a file structure. Portable executable format is an overarching structure of executable and object files. The portable executable and COFF, common object file format. You will also see this file type. These two files are actually called, falls in the portable executable format. And you typically see the exe file, right? .exe extension. Those files are also in this specific PE format only. And PE data is most commonly seen in hex dump of the executable file. Below we'll break down the hex dump of calc.exe, a typical benign application in Windows system, into sections of PE data. So they used that calculator application to showcase the PE structure. So here is the PE structure. To understand, to get the overview, see this diagram. Actually, it contains 7 or 8 components in it: DOS header, PE header, optional header, data dictionaries, sections table. Actually, these 5 components are belongs to PE header, and PE sections. I mean, the component of the content of the PE file. It contains code, imports, and the data. So these are the overall view of the PE structure. If you see here, the structure of PE data is broken up into 7 components. So there are 7 components around. That is what they gave here. And the first component is DOS header, DOS header. Uh, Defines the type of the file, and the MZ. So you may take any PE file. If you see the hex dump of it, it will begin with the letters M and Z. That is the DOS file header that defines the .exe file. And the DOS header can be seen in the hex dump of the section below. The DOS stub, there is another component, DOS stub. What it is yes, is a program run by default at the beginning of the file that prints the compatibility message. And this does not affect the functionality of the file, or I mean, for most users. So the DOS stub prints the message: this program cannot be run in DOS mode. If you see any executable, you can see any PE file, you can see this specific line: this program cannot be run in the DOS mode. This is what they gave here. So you can read it from here. The program cannot be run in the DOS mode. So that is called DOS stub. And the next stuff is PE file header provides PE header information of the binary. So here is the PE header, and that defines the format of the file, contains the signature, image, file folder, and other information headers. The PE file header is a section with least human readable output. You cannot read most of the stuffs here. If you simply see the hex dump, you can identify the start of the PE file header with PE letter. Apart from that, you can't read most of the characters, and that is its nature. And let's see the next header. Image optional header has a deceiving name and is an important part of PE file header. Just a simple explanation. Data dictionaries are part of image optional header. They point to image data directory structure. So again, a simple explanation. The next stuff is sections table. So this is a little important one. This will define the available sections and information on the image. Every image will contain set of sections. So that is what defined in this part. As previously discussed, sections store the content of the file, such as code, imports, data. You can identify each section definition from the table of the hex dump section below. You can see the different sections here. The first section, text. Second section, R data. Third section, dot data. Third section, P data. Fourth one, RSRC. Fifth one, sixth one, relog. So these are the various sections available in this executable. So that is what they gave in table format. If you see the section .txt text contains the executable code and entry point. This is very important. The entry point, that is where the specific program's execution begins. And dot data contains initialized data, strings, variables, and etc. If you handle any executable, you may use tool string to read the human readable strings in that executable. So those strings are usually stored in the specific dot data section. And if you see the R data or I data contains imports, the Windows API and other DLLs being used in that executable. And if it is dot relog, contains the relocation information, and dot RSRC contains the resource information, and .debug, another section, contains the debug information. So this is the overall simple explanation for all the sections that are available. Now let's try to answer the questions here. Uh, Simple advisory. P component prints the message this program cannot be run in the DOS. What is the component? Uh, DOS stub. So that is what we have seen just before. DOS header. DOS stub is the program run by default, and the DOS stub only prints this program cannot be run in the DOS mode. Compatibility message. So open the notepad.exe in detect it easy tool and answer the question below. So let's try to open this. Uh, so far we are in proc mode, and we need to open the detect it easy, the tool called DIE. So here is the tool I'm opening, and here is the notepad file. I am loading this notepad file into DIE. I just loaded it. So let's try to analyze this file in detect it easy. I already did this. What is the entry point reported by DIE? As we have studied, the entry point is stored in .text section. So we need to move to that specific section, and here I can see the section. I'm clicking this arrow mark. Here the .text contains the entry point actually. So let's try to uh, find the entry point reported by DIE. I can also see the entry point here separately. I'll be able to read this. Yeah, this is what the entry point, the detected TC, it displays the entry point at the top. And what is the value of number of sections? So we need to find the value of number of sections, and the number of section value is 0006. And there are 6 sections, that is what it denotes. And if I see what is the virtual address of dot data, so let's try to detect that virtual address of dot data. So if I see here dot data section, it has the virtual address of 0024 000. So that is the virtual address. Let me enter it here. That's the right answer. And what is the string located at the offset of 0001 F99C? So we need to find the string that is located in this particular memory location. So in order to find that, I am clicking the string here, and the specific location that we need to move. 0001 F99C. If I move further, little bit bottom, I can see 0001 F99C. It contains the string of Microsoft Notepad. Copy the string. Uh, yeah, I copied it. So here is the answer. So I copied it. Here is the answer. Perfect. Now let's move to the next one. The last section here. It is again a theoretical section, interacting with Windows internals. Interacting with Windows internals may seem daunting, but it has been dramatically simplified. The most accessible and researched option to interact with Windows internals is to interface through Windows API calls. Windows API is very crucial role. It plays crucial role. Windows API is the interaction point between any application and the system resources, and it provides the native functionality to interact with Windows operating system. And yes, that is. And the API contains Win32 API and less commonly Win64 API. Windows 32 API is the most common one, and we will only provide a brief overview of using few specific API calls relevant to Windows internals in this room. Check out Windows API room. That is a separate room in TryHackMe. Probably I can make separate video for that room. For more information about Windows API, hopefully I'll make that video soon. Most Windows internal components require interacting with physical hardware and memory. The Windows kernel will control all programs and processors bridge all software and hardware interaction. This is especially important since many Windows internals require interaction with memory in some form. An application by default normally cannot interact with kernel or modify physical hardware, requires an interface. And this problem is solved through the use of processor modes and access levels. So again, a theory concept. A Windows processor has user and kernel mode. So there are two modes in Windows processor, and the process will switch between these modes depending on the access and the requested mode. The switch between user mode and the kernel mode is often facilitated by system and API calls. In documentation, this point is sometimes referred to as switching point. So this is another important point to note. Here they gave the difference between kernel and user mode. User mode, no direct hardware access, but kernel mode, high privileged direct hardware access. And the user mode creates a process in a private virtual address space, but here the kernel mode they add in single shared virtual address space. Uh, and the third point, access to owned memory location and access to entire physical memory. So this is the crucial differences between user mode and kernel mode. Uh, Here also they gave the diagram to explain the user and the kernel mode. So this is the user mode or user land. Bottom there is a kernel mode. This is the switching point. So when they call the Windows 32 API, it brings the system calls and finally it calls the kernel. So this is where the switching point lies. And application started in the user mode or user land will stay in the mode until the system call is made or interfaced through API. When system call is made, the application will switch the modes. When the system call is made, the application will switch the mode. The pictured right flow chart. So this is the flow chart they gave. When looking at how languages interact with Windows 32 API, this process can become further warped. Uh, the application will go through the language runtime before going through the API. And the most common example is C hash executing the CLR before interacting with Windows. Okay. Um, I couldn't understand some of this point very clearly, but as a beginner, this is enough. We can try to learn and improve our skills gradually. We will inject the message box in our local process to demonstrate the proof of concept to interact with memory. The steps to write the message box, the memory outline below. So here is the simple exercise, injecting a message box into a process. So we are going to write a message box and we are going to inject that program into a process and make that, I mean, trigger that program. So the message box will appear. Allocate the local process memory for the message box. So these are the steps to do that. Write and copy message box to allocated memory. Execute the message box from local process memory. So this is the three steps that require. And the step one, we can use open process to obtain the handle of the specific process. So here they are using the open process function to obtain the handle of the specified process. And the step two, allocating the memory and virtual alloc yes, the popular string among the malware researchers and the threat researcher. And here is the code for that. And the step three, we can use write process memory to write payload to allocated region of memory. So here is the code. As step four, we can use create remote thread to execute our payload from memory. So these are the four programs and the four steps involved in this exercise in the process injection. And open a command prompt, execute the provided inject poc.exe and answer the question below. We are not doing any process injection in this exercise. We are simply going to execute an executable file that is already kept ready, and we are going to retrieve the flag. So let's try to do that. And now I am in the desktop directory, and this specific folder process injection POC contains the executable file which is kept ready, and I'm going to execute that file and grab the flag simply. So let me execute this. So here is the message box. This particular POC executed because through the process injection, and we finally received the flag here. So if I copy and paste this flag, that exercise is over. But before that, let's try to understand what is the component present in this specific CPP C++ file, and I'm opening it with notepad. So here is the code. Uh, the header main function contains some shell code and the virtual allocate x allocating the memory component. So here is the code. So this is the simple code for process injection. So let's try to execute the same thing again and capture the flag. And here is the flag. Now let's move to the last part, conclusion, just an advisory. Windows internals are core to how the Windows operating system works. This internal cannot change without compromising how the operating system operates at bareboard level. Because of this, the Windows internals are rewarding targets for attackers. And as mentioned throughout the room, attackers can easily abuse the functionality of Windows internals and components of nefarious for nefarious reasons. For more information about this, check out Abusing Windows. Many of the concepts covered in this room can even translate Unix counterparts, while specifics of the attacks and how they are executed may change. Many of the core concepts stay same. So this is another thing that you can keep in mind. Overall, Windows internals are here to say both and red team, blue team need to aware of their capabilities, including how they are used. So this is what all about this specific excellent incredible room by TryHackMe. With this, we successfully accomplished this specific room. And yeah, this is what I wanted to share with you. Hopefully, you have learned some new fundamental concepts from this video. If you did, please hit the like button and you may consider subscribing my channel. If you have any other opinion, put it in the comment section. I'll be reading those. And you can feel free to share this video among your friends. I'll catch you next time with another excellent video. Until then, I'm signing off. Cheers and love you guys.